Section 9.2 is about estimating a population mean. So in section 9.1, we found a point estimate and the corresponding confidence interval for the population proportion P. And in this section, we're going to do the same thing for the population mean, which is mu. And so again, in this section, we're going to be dealing with only sample data, and we're going to use this sample data to find out things about the population. In this case, the population mean. So we want to be able to find a point estimate and we want to find a confidence interval. So finding the point estimate for the population mean, we do that by finding the average of the sample data. That should just say data. And so we add up all the data values and we divide by n, which is the number of numbers or the sample size. And you've been finding average since you were in 4th grade. So I add up all the numbers, divide by the number of numbers. So example 1, the website fueleconomy.gov allows drivers to report the miles per gallon of their vehicle. The data in the table show the reported miles per gallon of 2007 Ford Taurus automobiles for 13 different owners. Obtain a point estimate of the population mean miles per gallon of a 2007 Ford Taurus. So I'm looking for the sample mean. So I'm calculating X bar. I do that by adding everything up. So I'm just going to put 28.5 plus 23.8 plus dot, dot, dot. I'm going to add up all the data and divide by the number of numbers. They tell me that there's 13 of them. I can add them up and see that there are 13 of them. So I'm going to add all them up, divide by 13. So 28.5. That's not what I need to do. 28.5 plus 23.8, 25.2. 26.3, etc. Everybody's day going. Hopefully you're not saving this for 2:59 on Friday. Hopefully I'm not making a typo. 313.7. So I add up all the data, get 313.7, divide by 13 to find that X bar, the sample mean, is equal to 24.13. I think it said to round to one extra decimal based on what the data was given. And so the sample mean is 24.13. That means the point estimate for our population mean is 24.13. Finding the confidence interval requires a little bit of background information. So we're going to introduce this concept of a t-distribution as opposed to the z-scores, which use the standard normal distribution. We are going to be using the t-distribution because with a z-score, you have to know the population mean and you have to know the population standard deviation. And even if we can approximate the population mean, I don't know anything about the standard deviation. So in this section, we're only given data about a sample. So page 440 to 443 discuss extensive requirements and properties of the t-distribution, but we will focus on a couple here. So the first one that we're going to focus on is that the t-distribution has the same general properties of the standard normal curve. Never touches 0, the area under the curve is 1, and it says see page 443 for more. So I loaded page 443 mainly just so you could see this picture. So it says the blue one is the normal curve, and then we'll talk about n, but it affects the t-distribution. So they look essentially the same. The main difference, though, is that the t-distribution uses the sample standard deviation S, as opposed to the standard normal distribution that utilizes the population standard deviation sigma. So the t-distribution uses S. And that's the reason why these are going to end up being close, but not exactly the same. So the t-distribution is appropriate if the population is approximately normal or the sample size is greater than 30. So I'm going to put a star here just because I know for a fact there are homework questions about this. It says if the sample size is less than 30, the t-distribution is accurate despite minor departures from normality. If outliers are detected, the t-distribution is not appropriate. So I know on the homework it's going to give you a picture of the normal probability plot and a picture of a box plot. and you need to be able to tell if there are outliers in those pictures. So if you need a refresher on that, let me know. But you're going to decide, yes, it's appropriate because there are no outliers, or no, it's not appropriate because there are outliers. So there's allowed to be minor departures, but there's not allowed to be outliers.